Algebra 2, how's it going? Just want to take you through this kind of weird, wacky looking geometry construction that I made. It's going to help us with our locus, not focus, but locus definition of a parabola. So just like the little point says right here, watch me, that guy, watch me. Watch that point and tell me if you see a pattern in what it's doing. All right, I'm watching that. He's coming down, down. Down. Looks like he's going to hit the line, maybe. Oh, he's pulling up just in time. Maybe he's going to land the plane. Yeah, he's going to land the plane, right? And he's going to land the plane. Nope. Nope. Look, not looking like it's like that scene in Con Air where they land the plane and then the plane takes right back off. Just like that. So very interesting. And if you didn't see the pattern, maybe you want to watch it again. And I'll help you out here. I will trace all the different possible little locations of that little watch me intersection. Well, let's take a look. All right, I got some green dots showing up there. Hopefully you can see them too. There's some green dots. There's some more green dots. We're just tracing all the different places the little watch me point goes. Hey, all right, that looks kind of familiar. Bring it over this way. Let's let that plane take off. And oh my God. Despite what you may have thought, geometry is not over. Geometry is still here because we just geometrically made a parabola. I think we can unequivocally say that that green line is a parabola. And you might be asking yourself, how did Mr. Thiner do this sort of witchcraft and wizardry? And I'll introduce a couple new terms for you guys. First one right here, this kind of floating point right here in the center. We're going to call that our focus. That's a piece, the word focus is a piece of our geometric definition of a parabola. The other line that really matters is this one, right down here, this horizontal line. That's got a fancy name. It's called the Directrix. All right, the focus and the Directrix. And this geometric definition of a parabola, it happens because of this special property. I'm going to measure two different segments here for you. From the focus to the green dot, and I'll measure from that spot there, those two solid pieces. Let me recolor them, make them a little wider so you can see them. And let's make the color, that's tough to pick a color out of that. Let's go with a nice bright red. And that shaded area, let's color that too in something similar to that nice bright red. So those two red lines, if I measure them, well, that one's 3.14. Oh, that's interesting. Illuminati confirmed. And we will measure the other one. It is also 3.14. And that's just in that location. If I move this point C, all right, well, now they're both 7.18. Let's get rid of that. If I move it back this way, they're both exactly 1.91. If I move it over here, we can get them to both be exactly 10.42. But this is the geometric definition of a parabola. All right? It is the set of points, that are equidistant from a line, and that's where we'll use this word directrix, and a point not on the line. And that point that we're referring to, that is our focus. All right? So that's the geometric definition of a parabola. You got this picture here to think about. Hopefully you now know the terms focus, and directrix. We will talk about those more tomorrow in class. And yes, oh yes, we will see how to work with these algebraically, because whether it's geometry or algebra, it's all math and it's all awesome. All right, guys, thanks for watching, and I will see you tomorrow in class.